Have you ever wondered what would happen if a supernova occurred near Saturn, the gas giant of our solar system? This is not just a hypothetical question, but a captivating cosmic puzzle that we're about to delve into. Supernovas, these brilliant and cataclysmic explosions, mark the end of a star's life, releasing an incredible amount of energy. They're cosmic firework displays that outshine entire galaxies, yet they're also creators, birthing elements that make up the universe around us. Then we have Saturn, the second largest planet in our solar system. A gas giant with an unmistakable set of rings, Saturn stands as a testament to the grandeur of the cosmos. It's a world of storms and winds, with an atmosphere primarily composed of hydrogen and helium. Now, pair the raw power of a supernova with Saturn's majestic presence. It's an intriguing, albeit daunting scenario. Now imagine the unimaginable. A supernova occurring right next to Saturn. A supernova isn't just an explosion, it's the dramatic death of a star. Now, to really understand this celestial spectacle, let's delve into what a supernova truly is. Imagine a star, not unlike our own sun, living out its days, burning brightly in the cosmos. But stars, like all things, have a lifespan. When a star exhausts its nuclear fuel towards the end of its life, it can't sustain the heat and pressure at its core. This leads to a catastrophic collapse under its own immense gravity. In a fraction of a second, the star's core shrinks from roughly 7,000 miles across to a mere 12 miles. This rapid collapse rebounds, sending a shock wave outwards that tears through the outer layers of the star. The star's outer shell is blasted into space, releasing an amount of energy equivalent to the total energy our sun will emit over its 10 billion-year lifespan. This incredible explosion is what we call a supernova, an event so bright that it can outshine entire galaxies and radiate more energy than our sun will in its entire lifetime. And what's left behind? A dense core, or what we know as a neutron star. But that's not all. The supernova also releases elements, seeded throughout the universe. Elements that are the building blocks of everything around us. Yes, that's right. The iron in our blood, the calcium in our bones, the oxygen we breathe, all were once part of a star that met its end in a grand supernova explosion. These materials are scattered throughout the cosmos where they can eventually coalesce to form new stars, planets, and potentially life. So, in a way, a supernova is not just the end of a star's life, but also the beginning of new celestial bodies. So this cataclysmic event, a supernova, is the death of a star, but it's also a birth of sorts, paving the way for new celestial bodies. Now let's shift our gaze to Saturn, the second largest planet in our solar system. This gas giant is not only one of the most beautiful planets, but also one of the most interesting. With its unique features and prominent place in our solar system, Saturn presents a spectacle of cosmic beauty and complexity. Saturn is predominantly composed of hydrogen and helium, similar to our Sun and Jupiter. Its gaseous composition gives it the classification of a gas giant. This planet is surrounded by an extensive ring system, which is arguably its most distinctive feature. These rings are made up of countless particles of ice, dust, and rock that orbit Saturn, creating a stunning halo around this gas giant. But don't let Saturn's beauty fool you. This planet is also known for its extreme weather conditions. Beneath its serene, golden-hued appearance, Saturn experiences violent storms that can last for months or even years. It's a testament to the raw and untamed power of nature, even millions of miles away from our home planet. Saturn is the sixth planet from the Sun, and the second largest in our solar system, only surpassed by Jupiter. It's located approximately 9 times further from the Sun than Earth, and with a diameter about 9 times that of Earth's, it's a truly colossal celestial body. Its sheer size and distance from our home planet make it a fascinating subject of study. Saturn's large family of moons is another intriguing aspect. With over 60 confirmed moons, including Titan, the second largest moon in the solar system, Saturn's gravitational influence extends far beyond its own body and rings. In the grand cosmic ballet, Saturn is a principal dancer, commanding attention with its size, beauty, and complexity. It's a gas giant that holds many secrets, some of which we have only begun to uncover. Saturn, with its majestic rings and gaseous body, is a wonder in itself. But what happens when it comes face to face with a supernova? The encounter between a supernova and Saturn would be nothing short of cosmic chaos. Now let's walk through this cosmic chaos step by step, shall we? First, as the supernova explodes, it would release a shockwave of energy and light. This shockwave would travel at nearly the speed of light, reaching Saturn in a matter of hours or days, depending on the supernova's proximity. Upon reaching Saturn, The first victim of this cosmic onslaught would be the planet's iconic rings. These rings, composed primarily of ice particles with a smattering of rocky debris, would be blasted apart by the shockwave, scattering into space like a cosmic snowstorm. The beauty of the rings, a symbol of Saturn we've all come to know and admire, would be erased in an instant. Next, the shockwave would hit Saturn's atmosphere. Comprised mostly of hydrogen and helium, the atmosphere would heat up rapidly, causing violent storms far exceeding the intensity of any storm we've ever witnessed on Earth. The heat could even ignite the hydrogen in the atmosphere, causing a temporary fiery glow around the planet. The impact on Saturn's moons would be equally devastating. Titan, Saturn's largest moon and a body larger than the planet Mercury, could potentially be stripped of its atmosphere or even shattered into pieces. Smaller moons might be completely obliterated or sent hurtling out of Saturn's orbit, becoming rogue bodies in the solar system. The effects of this supernova would extend far beyond Saturn as well. The shockwave could potentially reach Earth, causing disruptions in our own atmosphere and affecting our satellite technology. In essence, a supernova occurring near Saturn would be a catastrophic event, not just for Saturn but potentially for the entire solar system. It's a reminder of the immense power and unpredictability of our universe. The effects of a supernova on Saturn would be catastrophic, forever changing the face of this iconic planet. And as we'll see in the next segment, the aftermath of such an event would be just as dramatic and far-reaching. In the aftermath of such a cosmic event, Saturn would be a drastically different planet. Imagine, if you will, a celestial body, once renowned for its beauty and grandeur, now morphed into a realm of chaos and change. Its iconic rings, once a spectacle of the solar system, could be violently disrupted, possibly even obliterated. Saturn's atmosphere, primarily composed of hydrogen and helium, would be drastically altered. The supernova's shockwave would cause intense heating, potentially igniting nuclear fusion and creating a temporary star-like glow. This glow would eventually fade, leaving behind a planet that bears little resemblance to the Saturn we know today. But the changes wouldn't stop at Saturn. The shockwave would ripple through the solar system, potentially affecting other planets and celestial bodies. The orbits of nearby moons could be disrupted, and the debris from Saturn's rings might be flung far and wide, possibly even reaching the inner planets. Yet, amidst this chaos there could be a silver lining. The aftermath of a supernova is a fertile breeding ground for new celestial bodies. The immense pressure and high temperatures could cause the elements in Saturn's atmosphere to fuse, creating heavier elements like iron and nickel. These could then coalesce into new asteroids or even planets, adding a new chapter to the ever-evolving story of our solar system. Moreover, the event would provide invaluable data for scientists. The occurrence of a supernova in such close proximity to a planet is a rare spectacle, and the data obtained could greatly enhance our understanding of these powerful celestial events and their impact on planetary bodies. Indeed, the aftermath of a supernova near Saturn would be a spectacle of cosmic proportions, a display of destruction and creation on a grand scale, a testament to the ever-changing nature of the cosmos. The aftermath of a supernova near Saturn would echo through the cosmos, potentially reshaping our understanding of the universe. So, a supernova near Saturn would be a cosmic event of epic proportions. We've journeyed through the birth of a supernova, the essence of Saturn as a gas giant, and the potential collision course between the two. We've also delved into the aftermath of such a cataclysmic event. It's important to remember that these are all hypothetical scenarios, constructed from our current understanding of astrophysics. The universe, as we know, is a vast and complex tapestry, full of mysteries and events beyond our wildest imagination. The interaction between a supernova and a planet like Saturn is just one of the endless possibilities that exist in the cosmos. And while we've painted a vivid picture today, it is, at the end of the day, a speculation. While we can only speculate about such cosmic events, it's fascinating to explore the what-ifs of our universe. After all, the universe is full of surprises, isn't it?